All right, so let's go ahead and get started. This is your last notes that will be together. Wednesday, you guys will officially be transitioned to your sub. Which we'll talk about maternity leave after we finish your notes, but you've already taken 2 tests this quarter. You have 1 more test, test 3 coming up, and it only covers, it's a really short 2-day unit. So this is day 1. Next class, which will be when you officially have your sub, you'll have the 2nd day, and then you'll test on Friday. But it's a really short, really easy little unit, okay? So let's go ahead and do your notes first, then we'll talk about sub stuff second. All right, so a sequence, which is what your notes are on today, is, all right, we ready? Okay, ladies, gentlemen, here we go. Okay, a sequence is going to be a list of numbers that follow some kind of pattern. Okay, and we're going to call that pattern a function rule. Gosh, everything I have. Okay, pattern. And sometimes we'll refer to that as a function rule. Okay, when you're talking about numbers in the sequence, you're going to call them A1 if they're the first number in the sequence. So if A1 is the first number, what do you guess A2 is? Good. The second, what about AN would be the N number in the sequence. So the A little number is referring to its position within the list, okay? Then the function rule is going to be the pattern that you use to find each term in the sequence. So let me show you what I mean. Okay, we're going to do this 2 ways. We'll start with the function rule and generate the list. Then we'll start with the list and generate the function rule. So if I'm doing this first one, here's my rule. You are asked to find the first 4 terms. So the first thing I'm going to do is I'm going to write A1, A2, A3, and A4. And then I'm going to take those numbers, 1, then 2, then 3, then 4, and I'm just going to take turns dropping them into the n spot of the equation. So my equation, do you see that it says 4n minus 2? Then where the n is, I'm going to do 4 times 1 minus 2. And then I had you get a calculator just to make this a little bit quick. But what is 4 times 1 minus 2? It's going to be 2. Very good. Okay, then I'm going to change my n to a 2 for the second number. So it'd be 4 times 2 minus 2. What would that be? It'd be 6. Okay, next one. I do 4 times 3 minus 2. And you're essentially just swapping out what that n number is to get that next number. So my next number would be a 10. Okay, and then 4 times 4 minus 2, my last number would be a 14. Okay, then your sequence, remember what I said, it's just that list of numbers. So where it says sequence here, I kind of ran out of room, but I would put it's 2, then 6, then 10, then 14, ... Okay, and on your homework, it shouldn't ask you to find more than like the first 5. Okay? All right, take a look at the second one. My equation is n squared plus 1. Then I'm going to put A1 would be 1 squared plus 1. And then A2 would be 2 squared plus 1, where I'm literally just swapping out what the n is to plug in the next number. Okay, A3 would be 3 squared plus 1. And then A4 would be 4 squared. So because this question says to find the first 4 terms. That's how come I'm only finding the first 4. But if it said to find the first 3, you would only plug in 1, 2, 3. Okay? 1 squared plus 1 is 2. 2 squared is 4. 4 plus 1 is 5. 3 squared plus 1 would be 9 plus 1, which is 10. And then 17. And then once you find those numbers, that's the beginning of your list, and you can just ... Because like I said, the list does go on forever, but your homework's not going to make you find more than the first 4 or 5 of them. So that'd be 2, 5, 10, 17, ... Okay? Now, your sequences, there are 2 types. You have arithmetic and geometric. Okay, and the way that you'll know if your sequence is arithmetic or geometric is based on what type of patterns the numbers have. It is considered an arithmetic sequence if the pattern is either plus or minus the same number every time. Okay, and if it's a plus or minus pattern, you're going to call whatever that number is the common difference, or D. So it could be like plus 2 every time or minus 10 every time. Either one of those would count as arithmetic. Okay, it is geometric if it's a multiply or divide pattern. So under geometric, I want you to put times or divide. And rather than calling it a difference is only for plus minus patterns, you would call it a ratio. So we're going to use an R. So plus minus is a difference or a D, times divide is a ratio or an R. Okay, so real easy on these next 4 examples. We're just going to classify what type the list is. So this first one goes from 6 to 10 to 14 to 18. What's the pattern? Is it plus minus or times divide? Plus minus makes it which type? Arithmetic. So put a big A for arithmetic. And then we're going to put what the difference is. What is the pattern from number to number? Plus or minus how many? Plus 4 each time. So your difference would be plus 4. Okay, now take a look at number 2. Here are my numbers. 10 turns into 20, then 40, then 80. What's the pattern? Okay, times 2, that makes it geometric. And then would I classify that as a difference or a ratio if it's a geometric sequence? Ratio. So I'm going to put that my R is a times 2. But remember, you'll never have both. It's either a ratio or a difference, depending on which type. Okay, look at the third one. 180 goes to 60, goes to 20. What are they doing each time? Divide by 3. And if they're dividing by 3, is it arithmetic or geometric? Okay, put geometric. And then your ratio, if it's a divide by, instead of putting 3, I'm going to put a third to show that I'm dividing by 3 each time. Okay, versus if I put 3, that would mean I'm timesing by 3 each time, and that's not what I want. Okay, last one. We're going from 3 to 1 to -1, -3. What's the pattern? -2 each time. Does that make it arithmetic or geometric? Arithmetic. And that means that my difference is a -2. Okay, notice that -2 means it's a subtraction pattern versus +4 here meant I was adding 4. So you do want to think about which type of number it should be, a plus or minus. Okay, turn the page. All right, so if you have the numbers in the sequence, you should also be able to go back and write the function rule. So at the top, if it is arithmetic, meaning it's a plus or minus pattern, here's your sequence. You're going to do A1 plus whatever the difference is times n minus 1. Okay, write that down. Okay, but this is only if it's arithmetic that you would use that one. Okay, so let me show you what I mean. Take a look at your first question. Okay, my pattern is 1, 5, 9, 13. Can we tell what the difference is? Plus 4 is correct. So put plus 4 for your difference. Okay, then your function rule is going to be whatever the first term is plus 4 n minus 1 times. So let me show you what I mean. What is the first term in my sequence? 1. And then I'm going to add 4 each time, but not the first time. Okay, and I want you to think about why that n minus 1 is there. The n minus 1 is there so that for the very first number, you haven't added the 4 yet. So the first number stays a 1, and then after that, I'll add 4 each time. Okay, so if I want to skip ahead to, let's say, the 20th term in the sequence, but I don't want to have to write the list out all the way to 20, then what I can do is just pop that 20 into this spot, and I can shortcut to that answer. So for the 20th term, put a sub 20, and it would be 1 plus 4, 20 minus 1. And then you can just type that into the calculator and skip ahead to what that number would be without extending the list out that far. So in your calculator, can you type this in? I want 1 plus 4, but only 20 take away 1 times. Okay, or 19 times. So the 20th number in my list would be 77. All right, let's take a look at number 2. Okay, what is my pattern each time? I'm going from 7 to 2. It's minus 5. Very good. Okay, so my common difference is minus 5. And then remember, I have to start at whatever the first number is in my list. What's the first number in my list? 7. So it's going to be 7, take away 5, but not on the first. That's how you get the function rule, is I'm going to start with 7. I'm going to take away 5 each time, but not on the first number because I want it to stay a 7. Okay, then if I want the 30th term in the sequence, I can just pop that into this spot, and then I'll know what that number is without extending the list out to the 30th number. So it'd be a sub 30 equals 7 minus 5, 30 minus 1. Now, usually when I type these into the calculator, I'll just tell you I'm going to put 7 minus 5 and then just put 29. Because I know that if I want the 30th, I only need to take away the 5 part 29 times because it's always 1 less. So it'd be negative 1. Easy? Questions? All right, take a look at the next one. Okay, this one's a little bit different. You're not given the first several terms. Okay, you're given that the first term is a 22 and the 11th term is a 52. So here's what you're going to have to do to find your difference. You're going to do A11 minus A1 over 11 minus 1. Now, let's talk about why that makes sense. Okay, first question is, I want to know how much bigger the number got. So can you do 52 minus 22? How many would that be? 30. So my number got bigger by 30. Okay, but then the question is, how many numbers am I missing in the middle? Well, if I started with the first number and ended with the 11th number, how many numbers did I really skip? 11 take away 1 is how many? I'm missing 10 numbers. Then if it went up 30, but it took 10 turns to do that, then how much did it go up each time? 3. Does that make sense? So this formula is only if you're missing some in the middle that you're going to figure out how much did it grow, and then how many terms am I missing, and then divide those two things. Okay, so my difference is 3. Also, I'm acknowledging that it's a plus 3 because it's growing by 3 each time. And then I can write my formula. What's the first number in the list? 22. I'm going to add 3 each time, but not on the first one. Okay, and then right below that, you're asked to find the 13th term in the sequence. So you just pop a 13 into that spot right there. So it'd be a sub 13 equals 22 plus 3, 13 minus 1 times. And then from there, you'll just put that into your calculator. So go ahead and do that for me. Okay. And then that'll tell you exactly what that number should be. Okay. Without now 13, you could extend the list if you want to, but you know, the whole point is to skip to it. Okay. All right, take a look at number 5. Can you find your common difference using the formula I just gave you? So remember, I'm going to minus A13 minus A7. Did y'all get this answer? What was it? 58. 58? Thanks. All right, so for the next one, I would say, okay, I want A13 minus A7 over 13 minus 7. A13 is 18, take away 15. How much did it grow if it went from 15 to 18? Plus how many? 3. And remember, if I'm counting forward, 15 grew to 18, so it'd be a plus 3. But then I have to ask myself, how many numbers am I missing in the middle? So what is 13 take away 7? 6. Then if it grew by 3, but it took 6 times for it to get to that, then how much did it grow each time? Close? 1/2. I'm going to put 0.5, but 1/2 is fine. Okay, because it's 3 divided by 6. Now, if it was getting smaller each time, I would put minus 0.5. Okay, then we notice that we have a little bit of a problem. If I want to write the function rule, I'm supposed to know what the first term is, right? But I notice that in this case, I don't have the first term. The very first term I'm given is actually the 7th term. So if you want to work backwards, we're going to have to go backwards to find A1. So we already know A7, and we know that that's 15. How many backwards am I going to have to go to get back to the first term? I'm on the 7th number, and I want to go back to the first number. 6 times. And we're going to have to reverse the pattern. So in your calculator, type in 15. And then rather than me plusing 0.5 each time, I'm going to minus 0.5 6 times. So think about if that makes sense. The reason we're reversing the pattern is because we're having to work backwards. So if I start with 15 and I go backwards 0.5 6 times, that means my first term must have been a 12. Okay? So then I'm going to put A1 equals 15 minus 0.5 times 6, which is 12. And then remember, why did we need the first term in the first place? Because that's how you write the function rule. Is that you would put where your sequence starts, which now we know is 12. And then we're going to plus 0.5, but not on the first Okay. And then remember, you're only doing that if it asks you to find the function rule. Okay, that's what that's called, where you're writing the little equation to skip ahead. Okay. Then if it asks you to find the fourth term, you can just plug a 4 into that spot right there. So I would do 12 plus 0.5, 4 minus 1 times. And so 13.5 would be what the fourth term is in the sequence. Okay. Do we feel good about that? Great. Okay, so we did arithmetic. Remember, there's one other type. Turn the page and we'll do geometric. Okay, remember, geometric is when it's a times or a divide pattern. So I'm going to give you the generic equation at the top, then we'll just do some examples. Okay, for a sub n, it's going to be a1 r to the n minus 1 times. Okay, but remember, you only use this version if it's a times or a divide by pattern. So look at number 9. Can you tell me what the times or divide by pattern is as I go from 10 to 30 to 90 to 270? What are they doing each time? Times 3. So my r is a times 3. And then I want to write my function rule. Okay, for this one, my a1 goes on the outside. Remember, that's just the first term in the sequence. What was the first term in this list? 10. And then I'm going to times by 3 over and over again, but not on the first one. Then if I want to skip ahead to the 10th term, then I can just go ahead and put that in my calculator. So I'll do 10 to the times 3 to the 10 minus 1. And then remember, you're just putting that into your calculator. Okay? Now, one thing that I do want to point out is that your 10 minus 1 is an exponent. So when you type it in, make sure that you do it like we did on the last unit, where you use the little up button to get your 10 minus 1 to be small. So your 10th term would be 196,830. Now, one thing you will notice is that if it's a times pattern, the numbers are going to get bigger a lot quicker. Okay, versus if you're adding or subtracting, they're going to take longer to get unreasonable. Okay? All right, let's do number 10. Can you identify what your pattern is? I'm going to go from 80 to 40 to 20 to 10. Okay, we're dividing by 2. Then my ratio has to be a fraction. What fraction? 1/2. Or if you want to put 0.5, that's also fine. Okay, it doesn't matter which one you use. Okay, to write my function rule, my first term in my sequence is what number? 80, and then I'm going to cut in half over and over again, but not on the first. And then if I want to skip ahead to the 8th term, I can just plug in the 8 where the n is. Okay. So I'll do 80 parentheses 0.5 to the 8 minus 1. Okay, so that gave me 0.625. Okay. Questions on that? All right, number 11, can you identify what the pattern is? Divide by 10, very good. And if it's a divide by 10 pattern, what's my ratio? 1/10. So just remember that if it's a divide by pattern, you have to fraction it. Okay? And then I'm assuming you could finish that out. Am I good? Are we good on that? Okay. So let's just skip that one. Let's go to number 13, last one, I think, right? Yes. Okay, number 13, we're given the third and the fourth. So what happened from 18 to 48? So most of these are just nice, easy multiplies. Okay, but if I know that it goes A1, A2, A3, and A4, and it went from 18 to 48. So I don't know 1, I don't know 2, but I know the third is an 18 and the fourth is a 48. And then I'll just put dot, dot, dot. Okay, if it's a plus or minus pattern, you can just subtract to find the difference. If it's a multiply pattern, your ratio, you're going to have to divide the terms that are next to each other. So in your calculator, can you divide A4 by A3? A4 is 48, divided by A3 is 18. And then you're going to want to use the pretty fraction for this so that it reduces it for you, not as a decimal. So obviously, if it were an easy double pattern, you probably wouldn't have to do this. Okay, but for 18 and 48, we're going to have to find the fraction they're multiplying by. So we got 8/3. So your ratio for this one is 8/3. And what that means is that their pattern is more complicated. That the way that they get to the next number is that they're going to times by 8 and then divide by 3. Does that make sense? So it's like a combo pattern that you have a multiplier and a divider. Okay, in that case, if I want to work backwards, because remember, I need to know what the first term is in the sequence. Okay, to undo a times 8/3, you're going to have to multiply by a 3/8. So if it's a fraction, you're going to flip it to reverse it or work backwards. So in your calculator, let's start with 48 just to make sure we're safe here. We're going to times by 3/8. The next number is 18. Is that correct with what I was expecting? Yes, now I'm going to times by 3/8 again. The next number would be 6.75. And then I'm going to times by 3/8 again to get this number, which really I kind of want that as a fraction. So let me use the pretty fraction instead. Let me show you a different way to do it. Just use the pretty fraction, 3/8 times 3/8 times 3/8. Okay, but notice that I'm doing it the number of times that I would have to go backwards. So if I'm on the fourth term, I would multiply it 3 times to go backwards. So my first term is an 81/32. Okay. And then from there, you should be able to write your function rule. It's going to be 81/32 times 8/3, but not on the first one. Okay, but again, let me just stress one more time. Why in the calculator am I timesing by the fraction upside down? Because I'm having to work backwards to find the first term. But if you already have the first term, like if they give you the list, you don't have to do that step. Does that make sense? Okay, so you're done with your notes. Go ahead and pull out your Chromebooks. First scratch paper, will you just start with the back of your packet because it's already blank? And then if you need more, I'll bring you some. Okay?